Okay, let me do a few examples from iXL. I think this might be T2 because this was not covered right here in Big Ideas Math, and I didn't want to miss it. It's surface area. And this is probably my favorite thing in this whole section because what is surface area? Area of all the surfaces. Are there formulas? Yes. But if you think of surface area is the area of all the surfaces, then you're going to be just fine. For example, look at this green shape. The fact is it's a prism. It's a rectangular prism. But what matters here is what are all the different surfaces. This one's kind of like a tissue box. If you go and look at a tissue box, or if you actually have a prism, these fun little things that I have. You basically just need the area of all the surfaces and add them all up. So for example, check this out. This surface here, let's see if I can color it, is a rectangle that has the dimensions of 7 times 8. So the area will be 56. And guess what? If that's on this side of the prism, then the other side will be exactly the same. So every time you find the area of one side of a prism, the other side will be exactly the same. So it's 56 times 2. And then I'm going to have the area of this side here. And do you notice that that's 10 times 8? And that'll be 80. And again, there's that front and the back. So it's 80 times 2. And then we have the top. And that's going to be 10 times 7. You see the dimensions are 10 times 7. So that's 70. And guess what? The bottom is also 70. So it's 70 times 2. So this is how I like to write it. And then I say that equals 112. That equals 160. That equals 140. And I add them all up. So I'm taking each surface, finding the area, and doubling it. And then I'll have the surface area, the area of all of the surfaces. And so this is 2, 11 carry 1, 412, and this would be yards squared because it's just a bunch of areas, which is squared, added up. Okay? Now when we look at the cylinder, it's a little more complicated, but I know you can do it. And I think I showed you this in one of the videos, but check this out. Here's my cylinder. If I take out the center, this is like the coolest thing. Here's a cylinder. If I take a cylinder apart, guess what it's made up of? Okay, because remember, surface area, I want the area of all the surfaces. The top is a circle. The bottom is a circle. And if I take this apart, or if I take a label off a can, for example, it is a rectangle. And that rectangle's dimensions are the height of the cylinder times the circumference. The circumference will be the length of the rectangle. Okay, so let's do that here together. For the surface area, I have the circle, and then I'm going to multiply that by 2, because if I can find the area of the circle times 2, that'll be the surface area of the top and bottom. And then I need the area of the rectangle, which is called lateral surface area, by the way. And then I will add that all up. Okay, so let's figure this out. The area of the circle is pi r squared, all right? Radius is 5 because diameter is 10, and so the area is 25 pi. And if I double that, then that's going to be 50 pi. And we can figure that out in the calculator. Or you could say 25 pi times 2. It's the same thing. 50 pi. All right, so the area of both of the circles is 157.1. Okay, area of the circle, and there's 2 of them because there's one at the bottom as well. So that's part of it. And then to that, I'm going to add the lateral surface area, this rectangle. Do you see that with this rectangle? Let me see if I can erase some of this so we have more room. The lateral surface area is going to be this long rectangle. The height, or the length is, or width, sorry, is 9. And what is this? This, if you remember, wrapped around. So it's the circumference. The circumference of this circle is pi d, or 10 pi. So the area of that rectangle is 10 pi times 9, which is 90 pi. And I can put that in the calculator. Sorry, 90 times pi. Maybe I could put it in the calculator. And I get 282.4. Keep in mind, these are all approximates because we are rounding. And then when I add that up, add that to 157.1, and my total surface area is 439.8. Surface area of all the surfaces. All right, this is challenging, but I know you can do it. Okay, great job, guys. You guys are awesome.